Okay, I'm going to call this 1.85 because I wanted to slip it in before we get to polynomial and rational inequalities. So we're sort of revisiting some of these. So I'm going to run through this interval notation rather quickly here. But this is really set builder notation on right here, and then over here would be the interval notation. So x is greater than or equal to -2 would be equivalent to a bracket -2 to infinity. If you wanted to talk about a number that's greater than or equal to 4 and less than 9, so that would be an overlapping region between 4 and 9. But note that I used the bracket with 4 and I didn't with 9. That's because it says greater than or equal to. That means it includes the 4, and since it's just less than 9, it doesn't include the 9. So this just represents the numbers from 4 to 9, including 4 but not including 9. Now when you see an OR, it's usually a union of two sets. So it's a set of numbers. Here you've got all the numbers less than -6 plus all the numbers greater than or equal to 5. So that would be this set of numbers plus this set of numbers. And here we're going the other. We're going all the numbers between -1 and 5 inclusive. That means it includes the -1 and it includes the 5. Would be, you would use this would be the interval notation for that. And then I've got a few problems that go from interval notation and then you convert to set builder notation. Like here's the interval notation for x is greater than 3. Here's a union of two sets. The first set is x is less than, left out the equal to there, or equal to -2 because of the bracket, and then or x is greater than 0. There's no equal to there because that's parentheses. And then here you have x is greater than or equal to 3 but less than 7. So it's everything from 3 including 3 up to 7 not including 7. So it's two ways to represent sets of numbers. Now I've already covered linear inequalities, so I'm not going to spend a whole lot of time on this, but this first one I'm going to let you read it and you can walk through the steps and let me know if I might have made any kind of error. I don't think I did, but you can read through this. I just simplified the left side, simplified the right side. I got all my x's on the left, I got my numbers on the right, divided by -11 both sides, and then of course I have to flip the inequality over. And then this is just the interval notation for that solution. Okay, I'll go over this one because this one can be a little tricky. Here I have 3 minus 2x between -2 and 9. And of course notice over here we've got less than or equal to. So what I'm going to do is I'm going to subtract 3 from each of these terms. So I'll subtract 3 from -2. I'll subtract 3 from this. So I'll take the 3 minus the 3 here. And I'll subtract 3 from 9 here. And then I'll have -5 here. And of course up here the 3's cancel. So I get -2x. And 9 minus 3 is 6. And notice I just stay consistent with the type of inequality that I'm bringing down. Now from there I want to get rid of this -2. So I need to divide -5 by -2. I need to divide -2x by -2. And I need to divide 6 by -2. But remember, once I divide an inequality by a negative, notice that the inequality is reverse direction. Okay, remember anytime you divide inequalities by negatives, it changes their direction. So now simplifying, -5 over -2 is +5 halves. -2x divided by -2 is just x. And 6 divided by -2 is -3. Well, technically, this is written in the wrong direction. generally when we write an inequality like this, we write the smallest number first. So let's turn it around. And what you need to do, think of it as reading it from right to left when you do this. This says -3 is less than or equal to x. So I'm going to write down here -3 is less than or equal to x. And then continue reading right to left. X is less than 5/2. So x is less than 5/2 there. So we have x is basically greater than or equal to -3, and it's less than 5/2. And so that's the interval notation there. Now I didn't show you any number lines here because I did that on some earlier videos, but if you want to shade like the number line, you can do that. Now here's some applications of linear inequalities. This first one says find 4 consecutive integers whose sum is between 62 and 78. So I'm going to let those 4 integers be, since I don't know what they are, we're going to let the first one be x, and since they're consecutive, the next one must be 1 more than the first one, and the next one must be 2 more than the first one, and the next one must be 3 more than the first one. So these would be the 4 integers, x, x plus 1, x plus 2, x plus 3. So if you want to think about that, like if x was 3, then this would be 4, this would be 5, this would be 6. And so that's how you show consecutive integers. Now it says their sum is between 62 and 78. So what I did is I put the sum of these 4 integers here between 62 and 78. So all of this in the middle is the sum of those 4 integers. See, there's the x right there, and then here's the x plus 1, here's the x plus 2, here's the x plus 3, and of course they're all added together. Now when you add all these together, you just say x plus x plus x plus x is 4x, and then 1 plus 2 plus 3 is 6. So you just get 4x plus 6 in the middle. And now we want to isolate the 4x in the middle. So if I were to, the way I got from this step to this step, you ought to actually know by now, I just subtracted 6 from each term. So let me show you here. If you take 4x plus 6 and subtract 6, what do you get? 4x. If you take 78 and subtract 6, you get 72. If you take 62 and subtract 6, you get 56. And then to go from here, from this step down to this step, I just divided everything by 4. So if I divide 56 by 4, I get 14. If I divide 4x by 4, I just get x. And if I divide 72 by 4, I get 18. Now, notice, look at this real close. What does it say about x? It says x must be between 14 and 18. The only integers that fall between 14 and 18 are 15, 16, and 17. So that means for 15 we're going to have a group of answers, for 16 we're going to have a group of answers, and for 17 we're going to have a group of answers. In other words, the numbers 15, 16, 17, and 18, their sum would be between 62 and 78. The numbers 16 through 19, their sum would be between 62 and 78, and the numbers 17 through 20 would be between 62 and 78. So for each of these numbers x, we get the corresponding numbers x, x plus 1, x plus 2, x plus 3. And that's how we get 15, 16, 17, 18, 16, 17, 18, 19, and 17, 18, 19, 20, and so forth. Okay, number 2 says a bank offers 2 types of checking account. One account has a charge of $7 per month plus 2 cents per check, and the other account has a charge of $2 per month and 5 cents per check. And the question is, how many checks can a customer with the second account write if it is to cost less than the first account? So basically, let's just see what it costs for each account. We know up there the first account is the cost can be represented by $7 plus 0.02x. Okay, now I'm using 0.02 because I need to keep the units the same. and this is $7, and this is 0.02. 2 cents is $0.02. So 0.02 per check. And then the second account is $2 plus 5 cents a check, which would be 0.05 per check, or 0.05x. Now I want the second account to be less. So what I'm going to do is I'm going to write the cost for the second amount, and I'm going to write it less than, using the less than symbol, the cost for the first account. And then I'm just going to solve this inequality. Now all I have to do, if I subtract 0.02 here, subtract 0.02x here, okay, and then over here, you don't really have room to do it, but if I subtract 0.02x here, because I'm assuming you can do this in your head now, but so 0.05 minus 0.02x is 0.03x, right? And then, of course, over here it just cancels. And then to get rid of the 2, you subtract 2 from this side, and then of course you subtract 2 from the 7, and you get 5. So you get 0.03x is less than 5. Now all I have to do to solve for x is divide both sides by 0.03. So if I divide 5 by 0.03, it actually comes out to 166.7. But here's the deal. X must be less than 166.7. Well, obviously x is going to equal either 166 or 167, but x can't be 167. So, and x can't be a fractional number, so because you're not going to write a piece of a check. So let's just say x must be 166 or less. And then the third example here says if the temperature today ranges from 77 to 86 degrees Fahrenheit, what's the temperature range in Celsius? Well, Fahrenheit is equal to 9/5 C plus 32. So if we were to say Fahrenheit, like the Fahrenheit temperature is 86 to, let's see, from 77 to 86. And it says it ranges from, so that would be greater than or equal to, I'll fix that in a minute. And so it should be greater than or equal to 77 and less than or equal to 86. Now I'm just going to replace the Fahrenheit with the formula for Celsius. And so all I have to do now is subtract 32 from both sides. 77 minus 32 is 45. If I subtract 32 from this, it cancels the 32. And 86 minus 32 is 54. And then all I have to do is, to get rid of the 9/5, just multiply each one of these terms by the reciprocal of 9/5, which is 5/9. So I'll just multiply everybody by 5/9. And what that'll do, of course, the 5/9 and the 9/5 cancel, and I just get C in the middle. And then 5/9 times 45, well, we can divide 9 into 45 and get 5. And then 5 times 5 is, 5 times 5 is 25. And then we can divide 9 into 54 and get 6. And 6 times 5 is 30. So Celsius, if the Fahrenheit temperature ranges from 77 to 86 degrees, then the Celsius temperature ranges from 25 degrees to 30 degrees. So I've got some absolute value inequalities I want to do on the next video for you to wrap up this little intermediate section titled 1.85.